Hi everybody, my name is Jack. I am a colleague of Kyla's. We both work together at Thoughtbot. I'm going to be talking to you today about GameplayKit. I would like to thank Edward for naming this talk for me, nutting like GameplayKit. I didn't have a name, I just said I was going to talk about GameplayKit, and Edward gave me this, and it's good enough. So GameplayKit was introduced in iOS 9 and in macOS 10, 10.11 just last year. It basically provides infrastructure that is common to many types of games. It lets you focus on gameplay and on the rules of what your game is about instead of dealing with some of the infrastructure problems and plumbing and spaghetti code you can end up with by giving you some new architecture. It's got 7 different components. I'm not going to cover all of these in this talk today. It's not really quite enough time for that. So there's this thing called entities and components. There are state machines, there are agents, goals, and behaviors, there are rule systems, there's pathfinding, there's some randomization stuff, and there's this thing called the min-max strategist. I'm going to try and cover the first 4 of these, but not get to all of them. Because I wanted to take some time to sort of explain why these things are useful more than just what they are. Now, most of these things that are implemented in GameplayKit are not necessarily new. Like, you could pick up a book about game programming or about AI and find a lot of these things. What's new is that Apple is giving you these implementations so you don't have to do it yourself. It's kind of like no one enjoys, well, most people don't enjoy building their own like sorting algorithm. Some people write their own sorting algorithm, but not everyone enjoys it all the time. And like the same thing with like low-level networking code. It's nice you can avoid some of that stuff. And so that's kind of what's new here is that Apple is sort of giving you a hint, a direction to how you can build your app more than what they've had before. And this will, so basically it's a set of nicer high-level abstractions that let you take away some of the cruft you may have built up and maybe solve some architectural problems that you haven't even thought you had before. Before I go on, how many people here have actually written anything with SpriteKit, like a game? A little bit at all. And how many have done games and other things besides SpriteKit? So we've had a fair number of people done a fair amount of gaming work. So GameplayKit it's sort of framework agnostic. It's general purpose. It's not tied to SpriteKit or to anything. You can use it with SpriteKit or SceneKit, your own engine, whatever you want. The only real dependency is Objective-C and Swift. So you could be writing a game that is just something you run on the command line from the terminal and build it with Swift or Objective-C and build in GameplayKit and get all of its features. For some things it wouldn't be that useful, but for some things it could. The only thing that because it requires the native code aspect, it wouldn't work that well with something like Unity, which kind of runs in its own little bubble. It would be a huge pain in the ass to sort of map everything back and forth between these 2 worlds. But for anything you're writing that can interface with Objective-C and or Swift, these are pretty handy tools to be able to use. One of the main things that GameplayKit adds, again, it's all about this structure. And one of the biggest problems that I've seen in example apps I've seen, apps that I've written myself when I've started out doing games, is that it's easy to end up with this giant scene, this massive scene. It's kind of like in iOS programming and development, we fight against this massive view controller where all of your code ends up in this view controller. It becomes impossible to test, impossible to pluck things apart. And with SpriteKit, there's a tendency for this sort of thing to happen. It's pretty easy because in SpriteKit, like if you just start up a new project built with SpriteKit, I'm talking mostly about SpriteKit because that's what I've mostly been doing games in lately, but this applies to a lot of things. If you make a brand new project, Apple doesn't really give you much direction. You have a scene, an SK scene subclass, and that subclass it's set up that can handle input, it can deal with frame updates, it's going to take care of the node hierarchy and all the input management and physics. But all these things they're just primitives, they're just building blocks. And if you kind of stuff all these building blocks together into one single class, you end up with this giant mess later on. But unfortunately, that's kind of the obvious route. If you start a new SpriteKit project, that is the obvious thing to do, is start putting everything into that one scene. And that is not really what you want to do in the long run. It's just not that useful, and it ends up being you end up often being stuck. So one of the core things that GameplayKit adds is this idea of entities and components. And the idea is that instead of having all your code stuck into scenes, or even all your code stuck into SpriteKit node subclasses, you have these more abstract things called entities, where an entity is something that represents some object in your game. It could be a player, it could be an enemy, it could be a wall, it could be a missile, it could be almost anything. And the idea is that you don't want to actually even put a lot of code in your entities. You put code in components. Each component is one small bit of functionality that does a certain amount of thing. You might have a component that knows how to display something on the screen. You might have a component that knows how to steer a missile towards an enemy, these kind of things. If anyone has written any software using Unity 3D, it's pretty similar to what they do with their mono behaviors and all of the game objects in there. So this is a component-based architecture. It's the same kind of idea as Unity has. It's not exactly the same implementation, of course, but it's pretty similar in a lot of ways. Some of the naming is different, some of the usage is different, but it's pretty similar. So again, each thing in your game is probably going to be an entity. So here we have entities called player and enemy and missile that I've drawn up here. Each of these will be represented by a class called GKEntity. GKEntity you can use as is, but you'll very often subclass it to add properties that your entity has. Things that are beyond, well, it could include a location, it could include anything that affects what your object is and how it appears and works in the world, but without including functionality. You don't want to put a lot of functionality into your entity subclasses, just the data that they contain. Functionality instead goes into components. So what you do is you make a subclass of a class called GKComponent, and you add components to your entities. What this lets you do is you can write a component that knows how to do something, and then let any one of your entities be able to do that same thing. So instead of just writing code in your player class that knows how to do a certain thing, like how to shoot a missile, you write a shoot missile component. And then you can, once you've done that and that works, well, you can just go ahead and let enemies shoot missiles and let missiles shoot missiles. It gives you a lot of flexibility to sort of take smaller bits of functionality and apply them into a broader perspective. If you're not using this kind of architecture, what you end up doing, if you discover that you want to do this, and you've already written a player class and put your missile shooting code in there, you'll often end up saying, well, I got to make a superclass, a parent class that is a parent of player and enemy and missile, because all these things have to be able to shoot missiles. Instead, if you have a component-based architecture, you can have that as a separate item. And this component-based architecture is something that I've mostly only seen really used heavily in game engines, like in Unity and now in GameplayKit. But I think it has interesting applications in other areas as well. It certainly has been used in other areas as well, just not so much by me. And I just want to mention that the things in your game don't have to be visual. GKEntity does not have any rendering capabilities. Like I said, it's independent of SpriteKit or SceneKit or anything else. It's kind of abstract in a way. So typically what you would do is each entity, you would add one component that is a visual component that has a property that returns an SK node or a scene object of some kind. And you would set that up when you're creating all your entities. You would add give each entity a component that knows how to render itself as a sprite or whatever. Apple has good examples about how all this is done. I'll talk about that a little bit later. The next thing I want to talk about is state machines. One thing that every game has to worry about is state. Games are all about state and how state changes from moment to moment or from turn to turn. Is each character alive or dead? Is each enemy alive or dead or respawning? And also state in the form of what is the player doing right now? Are they looking at the game menu? Are they in the middle of the game? Are they paused? Are they on the restart screen? All of these things are stateful, and all these things impact how you handle input, how you handle display, all sorts of things. And if you just sort of dump all that code into your scene or into just even an entity object, you end up with a lot of long if-then or if-else chains. And these things are hard to debug and hard to extend and hard to just deal with in general. And up until now, there's really been no built-in better way of dealing with this. So what GameplayKit includes is a way of doing state machines. So you can skip some of this ad hoc, just sort of dealing with each little edge case as it pops up by adding one more thing to your chain of if-elses. And the way this works, it basically is for any sort of piece of state, you can create a state machine. Okay. So for instance, I'm talking here, I've got an enemy that has some particular state describing what is this enemy doing right now? Is it alive? Is it dead? Is it respawning? And so we have an instance of GK state machine, And when you create the state machine, you give it a list of states. Here we have states called alive, dead, and respawning. And each of those has to be a specific subclass of GK state. So you give it these 3 objects, and you also tell it, okay, the current state is this thing. The current state is respawning, or whatever it is. And then the idea is that whenever you have to make some decisions or do some functionality that depends on that state, you put that functionality in the specific state you want to deal with. So say we have a function that is like take damage. An enemy could have a take damage function. What you could do is you could make all of these 3 state subclasses all implement the same API. They can all implement a function called take damage, but the only one that actually does anything is in the alive state. If they're dead or if they're respawning, they can't take damage. But from wherever you're going to make the damage happen, you call that function anyway. You say, okay, give me my current living state and ask for its current state and call take damage on it. And whether that has any effect or not depends on that state. But you don't have to check it. You just sort of let it go. You let it do its thing. Each GK state subclass can also override methods to determine so that it knows when the state has become active, because you can set the current state on a state machine at a time. You can also set for each of these states, it can implement a method to tell the caller if it is allowed to change to another state. So for instance, maybe it makes no sense to be able to go from alive straight to respawning. So in your alive state, you can implement the method that says, hey, am I allowed to change to this state, to the respawning state? And it can say, no, you're not allowed to. So each state can sort of have control over which are the next allowable states in the kind of change graph here. The next thing I want to talk about is agents, goals, and behaviors. Because another pain point in developing games is trying to figure out where to put the code that's actually going to move objects around. You can put the code like in a scene or in each individual object. So if you have an enemy that's walking around, you got to figure out from each frame to frame where it's going to move, where is it heading towards, what is its next objective. If you spread that out among all your objects, things can be kind of messy, and you also lose some of the possibility of reusing some behaviors. So what this lets you do is you can define agents and goals and behaviors. And an agent is always going to be the GK agent class. The GK agent class is a subclass of GK component. So if you're already using the entity component model we talked about earlier, you can just add a GK agent as a component of one of your enemies, and it will work within that framework. If you're not using the entity component framework or portion of this, you can still use the agent framework or the agent portion of it on its own. But it's handy to be able to use that way. So GK agent contains properties describing an agent's physical characteristics, like its mass and maximum velocity. And these things are distinct from any sort of physics kit you're using or not using. So if you are using the built-in physics and sprite kit, you have to do some glue code to keep these things in sync. When you set up your objects, you have to make sure that, okay, I've set a physics mass on this thing. I'll set the mass on the agent. Each agent also has a single property called behavior that points at a current behavior. So each GK goal describes a particular goal that an agent is trying to achieve. That could be trying to reach for a target or trying to follow a path. There are some built-in ones. And these are all weighted. So each behavior can have a number of goals and say, okay, this goal has a high priority, this one a little bit lesser priority. So it's going to mostly try and follow this. And if it can achieve the other one also, that's just an extra sort of bonus. So there are built-in goals. There are built-in goals for avoiding other agents or obstacles in your world. There are goals for moving towards an agent. There are goals for maintaining relative positions towards other agents. You can implement flocking behavior quite easily with this. There are goals for following a path. And so each behavior you create is going to be one or more of these goals all stuck together. And then you can change in each agent, you can change that behavior as the game progresses. So you can have an agent that represents some enemy running around and decide, okay, at this point, they're going to stop chasing the player and start trying to defend their base or whatever. There can be you can have different behaviors and change them on the fly, however you want. Each behavior instance you create, you create it and configure it once. It can be shared amongst multiple agents. Likewise, each rule you create can be shared amongst multiple behaviors. So each of these instances you create is essentially a kind of an immutable little thing that you can sort of pass around and reuse multiple times. Another tricky thing that leads to spaghetti code is figuring out where to put the code that decides when you're going to make these changes. We talked about that each of these agents and the other entities can have both game states and behaviors that can change at any time. And this is something I'm sure you've seen in normal application development as well. Like you can implement code straight in an action method on a view controller, but that's not always the best place to do it. And the same thing here, like where is going to be the best place to change these things? So what GameplayKit also includes is a rule system where you can make several rules that are checked while the game is running at whatever frequency you determine is right to figure out if it's time to do something to make a change. The rule system typically will not make changes itself. Basically, you pass it a bunch of state, and then you say, hey, check all the rules against this state, and then I want to read your sort of output and tell me what you think of this thing. And basically the way this works is that every GK rule contains a predicate and an action. And the predicate is basically a question, like, is there a pile of dead enemies? If there's a pile of dead enemies, we might have a situation where the enemies on a level in your game, they react differently as time goes by. Maybe they start off pretty calm and cool, but as you start to kill more enemies, the remaining enemies, they start to panic more. And instead of hard-coding this into your scene by saying how many dead enemies are there, you could create a rule that is a separate thing. And so when you ask the rule system, hey, what's going on, it can sort of check. And the way that this happens concretely is that each rule can influence one or more so-called facts. In the rule system, there are a number of facts. A fact is basically just a string, the identifier. You can think of it as having a dictionary where the values are strings, or the keys are strings and the values are numbers. And so whenever a rule is found to, when its predicate is found to be true, then the action of that rule can be, okay, say I have a rule that says, okay, I found 3 dead enemies within 5 meters of this character's location. Then I'm going to increase the value of the panic fact by 10 or something. And then at the end, so after all the rules are run, you can read out the values out of the rule system and say, okay, what is the value of the panic level? Okay, that value, I'm going to take that and insert that straight into all of the relevant components that all of the enemy characters have. So without having code in your controller or your scene that is sort of managing all these things and trying to figure something out, you can just pull a value straight out and pass them on to the other ones where they belong. So you avoid having a lot of stuff that requires complex testing in your controllers. You just kind of pass things around. I think I said everything I was going to say about that right here. So what else? There's more stuff in here that I did not even talk about at all. Like I said, there's a lot of stuff in here. I want to kind of touch on what I saw as being the most general purpose useful things. There's also pathfinding, which is very cool. There are actually 3 or 4 different algorithms of pathfinding it implements for determining how objects can move around your game world. There's randomization, giving you different strategies and a variety of ways to generate random numbers and random sequences. Always with seeds, so things are reproducible if you want to. And there's also an interesting thing called the min-max strategist. This is mostly for turn-based games. If you imagine like a board game where you can see the whole state of the game, say chess. And you could say, okay, based on where the positions are, I can calculate a numeric value for the entire board right now, like who's winning and who's losing. And you can compare that with another game state and use this to let the computer generate either good moves for a computer player or generate hints for a human player, saying, hey, this might be the move to make, that sort of thing. So those are the other parts that I'm not going to get into at all. There are resources. The best resource right now that I've seen is Apple's GameplayKit programming guide. It's actually very extensive. There's a lot of sample code. There's like a half dozen applications. I especially recommend they all seem good. All what I've seen so far. They're all quite new. Came out last year. Some mix of Objective-C and Swift. The most detailed and complete is pretty much a full game called DemoBots, which is actually a pretty fun game that they've created, and it kind of exercises pretty much every part of GameplayKit. So it has all the things I've talked about, plus the things I just mentioned in passing. It probably does not have the min-max thing that I mentioned. But pretty much everything else that I talked about is going to be in there. And just Google that, Gameplay Programming Guide, and GameplayKit Programming Guide, and you will find it. That's all I had for today.